Okay, good morning everybody. Yesterday we looked at this powerful object-oriented programming principle of composition. Composition in practice is very easy to use. All you need to do is you use an object of an other class in your classes. For example, this holiday class contains this data member, which is of type day of year, and I kind of compose these two classes together to come up with a simple to explain, simple to implement, simple to maintain class holiday. This holiday class includes lots of functionalities, but it doesn't care about how the date is handled, how the date is initialized, it is input, it is output, or it is validated. Okay, all the date related stuff has to be handled by the day of year class, by this object. Okay, by the way, let me come back to this one. Yeah, you see this one previously, what did we call this part? This part is, we learned it yesterday, we call this part initialization section, right? The initialization section of the function header. We said that we prefer initializing our objects, data members, in this section instead of putting them inside the body of the function. And I said it is kind of more efficient. Why? Because if I don't do this, okay, the alternative would have been like this: date dot set, okay, month and day. Okay, the alternative would have been this. If I don't do this, let me take it out, and of course where is my cursor? Okay, so what is wrong with one? I mean, with this one nothing is wrong. It would work the same way because I am setting a new date to my date object. But the thing is this: to be able to set the date, okay, there has to be a date object. Okay, how did I create the date object? Okay, compiler automatically created one for me using the no parameter constructor, right? So it was created with the no parameter constructor. What did the no parameter constructor do with the date object? Where is my date? Okay, no parameter constructor here, it just initializes one day of year object with January 1st, right? So what I am doing here is I am initializing a temporary object with January 1st, and then I start my constructor here, holiday constructor, and I am setting my date again. So I'm doing two things unnecessarily. Creating an object, initializing it to something January 1st, which is unnecessary, and then I'm setting it to something else. Okay, so we don't prefer it this way. The better way of doing it is, okay, let me copy this and put everything back. Okay, like this. Okay, and we don't prefer it this way. The right way is the above. Okay, you see the difference, right? I mean, functionally there is no difference. I mean, the outcome would be exactly the same, but this one is more efficient than this one. Okay. Again, I'm telling you this because, okay, there's an efficiency issue, but also the issue of composition. I mean, composition is important. Object-oriented programming principle, yes, that's true, but how we are doing the composition and what kind of concerns we should have about the composition in terms of efficiency turns out to be this. So use this initialization section to initialize your data members. Otherwise, your code will be a little bit slower. It doesn't matter much for the case of booleans or integers or doubles. Okay, that's what we had previously. But now we have large objects like the date object, day of year object, right? So creating it with a constructor like this one. Okay, this one creates this when this 57 starts. All the objects in your holiday object are initialized and they are constructed. And now I am turning back and I am setting it to some other value. Okay, so you understand this, right? Do this. When you understand something, do this. Okay. You can. Your neck doesn't move. It moves. Just do this. Everybody, I am talking to you. Okay. Do it like him. I don't know what is wrong with you guys. Maybe something is wrong with me. Yeah, okay. Okay, this is good. We talked about this, and composition is important. Again, two things we should keep in mind. What is composition, why we are doing it, and how we do it. Okay, this is how we do the composition. And actually, you have been doing the composition all over. Why? Because you have been using integers and doubles in your classes. And those classes are not your integers and doubles are not your classes, right? So you have been doing it, but I mean, when you use integers and doubles in your classes, I mean, you don't feel like you designed both of them. But here, in this case, we designed both of them, holiday and day of year, and we will keep using this a lot. This is again one powerful feature. You don't try to, if you don't use composition and those kind of techniques in object-oriented programming, that means that you will end up with just a single large class. Okay, it's like writing your whole C program using a single main method, right? So you don't do it. I mean, is it possible to write the whole C program using a single main method? Yeah, of course it is possible, but we don't prefer it that way. Again, when you are writing C++ programs, object-oriented programs, you design many classes and these classes interact, and composition is one of the many ways of interacting the classes together, and it is one of the more important ones. Okay, and there is a example in the book, bank account class. Let's go to the bank account class. I think it is which one? Maybe this one? No. 7. Oh no, not this one. This one, yeah, bank account. Okay, let's look at the interface of the bank account. Nicely commented. It says that I have a bank account. I am initializing it with a double balance and a double rate. This is the interest rate. Okay, interest rate and double balance. And at line 14, I have another constructor that will take two parameters. The first two parameters are again for the balance. I am going to represent the dollars part with an integer, cents part with an integer, and the rate is just a double. And the third one is just the same as before. This one now doesn't have the cents because it will take the cents as 0, 0. And the bank account, no parameter constructor, it initializes the account balance to 0. Okay. It initializes the bank account to 0, 0. Interest is 0, 0. Update is a function that will do this. 1 year of simple interest has been added to the account. That means that rate times balance will be added to the balance. And input, output, get balance, get dollar, get cents, and get rate are the functions that we already know. We don't know about this const thing. I mean, we know what const keyword is, but we have never seen such a thing before. Let's try to understand what this one is by looking at our slides. Okay, so we previously knew that there are two ways of passing parameters to the functions: call by value, call by reference. Okay. If we pass pointers to the functions, it's kind of simulated call by reference, but I will ignore it for now. Call by value. There are some features of call by value that we like. What is the main feature that we like about call by value? When you pass an object to a function with call by value, a new copy is created, and whatever change you make on that parameter will be the copy, right? So your original parameter will not change. That's what we like. But the bad side is you have to make a copy, and making a copy is expensive, especially if you have large objects. Okay, and that's why we have call by reference. Call by reference is okay, we have many people today, and in fact I have just 2 spots available. Let me start from the other side so that it ends up in So call by reference, we like it because it doesn't copy stuff, but there is a danger of function by accident changing your data, etc. So the solution is, we remember, call by reference by const, modify in the parameter list. Okay, so that's what we do. If you are passing an object to a function, okay, and if that object should not change by that function, then we pass it with call by reference. Also, we pass it by constant modifier. Okay, so that's what we do. Okay, so large data types, typically classes. Okay, we pass them call by reference. That's the rule. Okay, the rule is this: if you have a function, okay, and if you are passing a class object, then you pass it like my class with a const reference. Okay, so that's the rule. Well, can we do this with the integers and doubles? Well, you can, but I mean, you don't gain much with the call by reference, constant reference of integers and doubles, because you have to pass something to the function. That's usually the pointer under the hood. The pointer is being passed. But passing a pointer and passing a reference is no different in terms of efficiency. So we don't do this with the integers, doubles, and the fundamental types. Okay, but for the object types, definitely we pass them with a constant reference. That's the rule. So if I go back and if I make some changes in this, I don't have it in this one. Maybe, yeah, holiday. Remember this one should have been a constant reference. Constant reference. Where is my? Okay, I found it. Okay, so this is how it should be. A constant reference object is being passed to this constructor. Okay, so constructor will not change it, we know that, and there will be no copy making while I am calling this constructor. Okay, that's one thing. Good. Okay, so large data types, typically classes, these are able to use pass by reference. Okay, even if the function will not make any modification, but you just make sure. Okay, use constant parameter. That's one thing. Let's look at this one. I mean, let's try to remember what we did in the C days. This is what we did, right? We had a struct definition. Okay, and we say struct, for example, day of year, and then I would define integer month and integer day. Okay, this is my day of year struct. I'm writing this in C. If I don't make it a little bit smaller, it won't fit. Okay, so let's say I like to write a function output. how would I write it? I would say output, let's say I have a struct. Let me use a C++ syntax, okay, like that, struct, okay, day 1 and day 2, okay. So let's say I have a function named output, and it will take a day of year object, okay, day of year object. Just to make this more efficient, I will say I will get this, right? So remember previously, I mean, in the C ways of doing it, this is C, okay, in this is, sorry, C++. In C++, there is a way of saying this output. That's why I don't pass parameters to output function in C++, because this is my object and this output will work on the object. But in C, I don't have the objects. For the functions, global functions, I have to pass everything that they need, right? This is what I did. So what would I do to this function if this function tries to modify this object, okay, this struct? I don't want output to change anything about that D, right? What would you do? You will say, okay, don't change anything on this object. I am putting a constant on top of it, right? So I know that this function will not change this day of year object, right? This function output. This is how we do it in C. How about in C++? How can I achieve the same thing in C++? All I am doing in C++ is this, d1.output, okay? How can I make sure that that function output of class day of year will not change anything about that d1? Where do I put that const keyword, okay? That's the thing, okay? How do I get the help? What is the function of const keyword again? While I am implementing this output function, if I change something by accident without realizing it, the compiler will object. It will say, no, you cannot change anything about this object D, okay, day of year object, because it's a constant. I like to have the same help from the compiler when I am implementing this output function of the day of year class in C++. So how am I going to achieve the same thing? That's where the const keyword with the member function. Here you are saying that, okay, my function output will not change anything about the object. Okay, it will not modify the objects. My function getBalance will not change anything in the object, and the same thing for the $and getSense. Okay, so you put your const keyword at the end of the function declaration, saying that this function is a constant function, and it will not modify your object, my object that is being worked on. Okay, good. So this is where we put the const keyword. So I mean, there is not much new about that. I mean, if I had a global function, then I put these const keywords in my parameter list. But now this is not a global function. It works on an object. But how should I make sure that that object won't change? I put a const keyword in here. And of course, since output is a const function, we call it that way. Output cannot call input. Why? Output cannot call input.
Because input is not a constant function.
Yeah, because input will change the object, right? Input is going to change the object. Okay. How about just the opposite? Can input call output?
Yes.
The object is just the opposite is acceptable. The function input can call output because the function input can do whatever it wants, change, not change. Okay, it is up to the input. But output says that output makes a promise. It says that I promise that I will not change anything in this object. All I'm going to do is just read it. Okay, so a const with member functions is important. Why? Why are we using the const keyword again? Because of the principle of least privilege, right? We are trying to restrict our customer, okay, and ourselves. And customer, while they are using this, okay, customer, while they are using this, they will see that output will not change anything about the object. Okay, good. Let me make, okay, this is bank account, right? Bank account. Let me make an object here. Bank account. I will do it bank ACC. B1 and B2. Okay. And of course I can say B1 dot input, no problem, and B1 dot output. No problems. Okay, no problems. And I know that by looking at these function declarations, member function declarations, input may change the object itself, the B1 object, but output will definitely not change it. So this line will not change the object itself. I know that one. How about this one? If I have a constant bank account object, okay, constant bank account object. Now I am trying to, I keep doing the same mistake. I'm writing too big and I have to do this all the time. Okay, so when I say cp dot output, everything is fine, no problem with this, no problem, no problem, no problem. But when I say cb dot input, okay, the compiler will give me an error message, right? Why? Because input is a non-const function, okay? We call them, okay, these are const functions, const function, 4 of them. But input is a non-const function. It can change the value of CB, but CB is a const object. It cannot be changed, okay? So this is not possible.
Teacher, can I ask something?
Sure.
If I want change one variable and the other one should const, can I do something?
You like to change one of the variables? You mean
change the other one will
what
stay.
do you mean variable? Variable by
Month,
object?
day and month in our class, day of year. Example.
Yeah.
Can I change one and the other one will stay constant? We do all of function constant.
Well, sure. I mean, in that case, it is in your. In that case, it will be in your class definition, and you say that my month will always be constant like that. Okay. So when you create your object, you have to initialize your month in your constructor because this one has to be initialized, right? You initialize it in your constructor. Later, nobody can change it. You make that sure, okay? So this is constant in your object, not in your class. You know the difference, right? Month will be constant for every object, but for different objects, it may change its value. That's why you have to initialize your month in the constructor. Once you initialize your month in the constructor, okay, it will stay the same for the life of the whole life of the object, but different objects can have different month values. So month is not a constant for the whole class. Okay, I hope this makes sense. Good. Let's go back and let's look at this one again. Any questions on this? Why I put a red mark in there? Any questions from the online people? I am sorry I muted you again. Well, I am not that sorry because you are not asking any questions anyway. Any questions from the class? Okay.
Hocam,
yes?
can I ask something?
Sure.
If I define my private variables const, can I get rid of the get function defining cost?
You mean
could I ask-
if everything is a const in your if everything const in your class definition, you are saying that you don't need these constants anymore, right? Is that what you are saying?
So your voice is interrupted. I couldn't hear you.
Okay, you are saying that if you declare all the data members constant in your classes, then you don't have to use these const keywords in these
Yes.
yeah. Well, I mean, first of all, if you do it that way, I mean, if you declare everything constant in your classes, your input will not work, right? Because you are not changing it. Also, your set function will not work. So you have to get rid of those. Okay, that's one thing. The other thing is that this const is for the compiler to say that I am not going to change anything on this object. Okay, I am not going to change anything on this object, and the compiler doesn't check what you are doing inside the function actually if you don't put this const keyword in there. So let me try to give you an example. Okay, let me do this. I am not going to change anything in my code. Okay, let me go to the definition. Where is my definition? Is here. Okay, so let's look at this output function. I am just erasing this const keyword here. Okay, I just erased the const keyword. Okay, I just erased the const keyword for the output. But I know that in my output function, I am not changing anything actually, okay? But there is no const keyword in here. Okay, so this is what I am going to do. Let me go to the main function if I can find that. Where is my main? Did anybody see the main? Okay, here's main. Okay, here is main. In my main function, I will do this. Okay, this is account 2, or maybe I should do const bank account B1. Let's initialize it with 110 or 20, whatever. Okay. When I say B1 dot output, do you think this will compile?
Yes.
Well, since I am keeping my silent, the answer is not yes. Take another guess. Yeah, the answer is no. And you know the next question, right? Why? Who asked that question in the Teams page? Okay, who did ask the question? Who was it? Me. What is your name? Me. Okay, Ayşegül. Okay. So Ayşegül, tell me why line 69 would not compile. Because I know that output doesn't change anything, right? Output doesn't change anything. It just outputs stuff. All I did was remove the const keyword from the output function definition. That's what I did. And now I am saying that this b1.output will not compile. Because the compiler say that b1 is a const. Okay, b1 is a const object, right? b1 is a const object. On the const object, you can only call const functions, and output is not a const function. It doesn't matter if you are changing something in it or not. Output is not a const function, it's a non-const function. So compiler will not let you compile this line. To be able to compile this line, output has to be a const function. Back to your question. You said that if everything in my class is a const, that means that I am not going to change anything. Can I get rid of those const keywords? Well, if you get rid of const keywords, like I get rid of this const keywords, your functions will not work on const objects. Compiler will not allow it. Got it? Ayşegül, are you there?
Yes.
Okay.
Yes.
Okay.
Thank you.
So that was a good question, and again, this is the way I like to think about learning new stuff. Always ask these kind of questions to me, or most importantly to yourself. Okay. Can I do that? And can I do that? Okay. I didn't tell you anything new actually. I mean, I repeated what I said before, but giving this example is kind of gives me another opportunity to talk about it more. So const means that, okay, const means that, output const, a function being const, it will not modify anything, and compiler knows about it. If you don't put a const at the end of that function definition, the compiler will not let you call that function on const objects. Okay. You might think that why doesn't the compiler go into the function and see if nothing is being changed? Inspect the output function, okay? Inspect the output function and it sees that nothing is changed, so I can make this call, right? Because output is not changing anyway. Output is not changing anything anyway. But compiler cannot do that. Why? Why can't the compiler, when it looks at this line, go to the definition of implementation of output, see if anything is changing? If anything is not changing, then allow this one to be compiled. Compiler cannot do that. Why? Okay, let's go to the beginning of the program. This is my class definition, okay? Bank account, all of my functions are nice. I put everything, and now I have my main function. Inside my main function, I am calling this output. Compiler cannot go to the implementation of output and say that, oh, nothing is being changed, so this b1.output is okay. It can't do that. Why? Because while compiler compiles 69, yeah, you complete the sentence. Abdullah, you complete the sentence. Because while the compiler compiles line 69, it does not know the implementation of the function output, right? The implementation of the function output will come later. Maybe it is in a different file, right? To be able to compile this line, all the compiler needs to know is the prototype of this function output. That's it. The compiler knows only this line. That's it. It doesn't know anything more than that. Okay? It doesn't need to. And if it says no const function here output, the compiler will assume that it's a no const function. I will not compile line 69. But things have changed. If I do this const, okay, it will compile it. And how about this one? If I do this const here, okay, if I do this const here, I know I'm making a mistake now, line 27, and come back and do this, b1 dot input. Okay. So tell me, there will be an error message. Where is the error message?
The implementation of the input function.
Yeah, implementation of the input function, exactly. Because I promised to the compiler that input will not change anything. Okay. I promised that, and output will not change anything. So it will compile these lines nice, 69 and 70, no problem. But when it comes to the function input, implementation of the function input, as soon as it hits this line, 147, it will say that, no, not that one. Yeah, account dollars and account set, because these are the member variables. Okay. and it will say that no, the assignment to const object variables are not allowed. Okay. Okay, thank you, Ayşegül. Ayşe. Was it Ayşegül or Ayşe? Which one? Ayşe. Okay, thank you, Ayşe. You asked a good question.
You're welcome, sir.
Okay, thank you again. Any question?
Sir, I have a question.
Yeah.
Can we, I don't know if it's possible, but can we set our code in a way that compiler knows output function will not change anything, but it also doesn't have constant? So
Will not change anything, and no, I mean, if the output function doesn't change anything, you should mark it as const. Okay. There is a good statement in the book. There was another question? Yeah.
If I don't define const by bank account in 67, can you come?
67, yeah, what?
If I don't define const by bank account, but I define example dollars, const dollars in private section, it's still compiler. I don't define const.
You are saying that you are
one variable
define this a const?
Yes.
This one.
Yes.
Well, if it's a const, then none of your functions can change it.
Yes. This is compiler.
Sure, yeah. Well, I mean, if this is a const, intake count dollars, then none of your functions, doesn't matter if they are const or not. Okay, they won't change it, other than the constructor. Constructor can change it. Because if the constructor cannot change your constant variables, then what is their initial value? I don't know, right? So constructor against special ones. Okay, let me go to the book again. Book says that all or nothing use of const. Using const is something nice. It enforces the principle of least privilege, information hiding, restricting the user. These are all nice stuff. Okay, these are nice stuff. But once you start your const, you cannot say that it is up to me to make this function const. Remember that output function, if you don't make it const, it still compiles, right? Okay. If you don't make it const, but you cannot say that I am going to use const in one part of my program and in other parts I will not do it. It won't work that way, okay? Either you start using const or you don't use const at all, okay? Because if you don't make your output const, then it cannot work on the const objects, right? So either you are going to use const properly everywhere that is applicable, or you won't use it at all, okay? So if you don't use the const keyword at all, you will not get a passing grade from this course. You will fail, okay? I will make sure that. Okay, that's very important. That's very important. So you are saying that you can fail from this course, you can get an FF from this course by just omitting a keyword that is unnecessary, right? The const is unnecessary. Const is unnecessary if your program compiles and runs. Okay? So you might think that, well, what kind of a logic is this? And this is the logic of object-oriented programming. I mean, nobody tells you that you should write your program in C++ or Java. C is fine, assembly is fine. Okay? If you can do it, if you can find a job, if you can survive in this world of software engineering or computer engineering without using object-oriented techniques, then you should be fine. But if you are doing the object-oriented programming, then you should apply these principles. Even though if you do it the other way, your program compiles and runs. No, we don't do it that way. We hide our information. We use private section, okay? We use encapsulation, idea of encapsulation. We use the idea of composition. That is what the object-oriented programming is. Okay. Good? Okay, let me go back. And yeah, this one. If no need for function modifications, protect parameters with const and protect all such parameters. And that includes the class member functions. Okay, so use const whenever it is applicable. Okay, for the function parameters, if you are not modifying them, pass them using const reference. And if your member function parameters, member functions are not modifying your objects, then again make them constant. Okay, using this idea, let's go back to our program again. This one, okay. This is our bank account again. When we come here, bank account, of course, a const constructor is not possible. I didn't try it, but if you put the const keyword here, most probably you will get a error message at line 22, not at the implementation, because the meaning of constructor is you initialize something, right? So const constructors is not possible. Doesn't make any sense anyway. And I don't know if there's a compiler or not. The update, of course, is not a const. These input, of course, input is not a const. Let me change it. Output is const, and these are my const functions. They are all const. Of course, set balance, both of them, both overloads are not const, and this is not const. In my private section, I have, there's a question?
Yeah, sir. Can I ask something?
Sure.
Sorry, I missed that. When we write the get dollar const, which data we are protecting? Sorry, I missed that.
Get dollars and get cents. It says that when you call get dollars and get cents, nothing in your class variables, okay, data members will change. That will include these three lines, okay. So because in my class I have three data members, account dollars, account cents, and rate. Other than that, I don't have any.
Just definitions.
Say it again.
Just variables, right?
Sure. Well, what else can there be? I mean, you cannot change the functions anyway, right? The only things that are changeable in my objects, bank account objects, are these three variables, data members. There is nothing else. Okay. When I make a new bank account, object, okay. When I make a new bank account object, okay. Let's look at this picture. Okay, so it is like, this is B1. Inside B1 I have an integer, another integer, a double. Okay, this integer is dollars, cents, and the rate. I have B2. Okay, again, integer, and double. And I have BC, constant bank account. Again, integer, and double. Okay, this one is const. You are not supposed to change it because you make a promise. B1 and B2 can be changed. Okay, these are our objects. I mean, our class might look complicated, but when you make a class object, all you have in your memory is the member variables, member data, right? So when you look at this memory, configuration, you don't see anything different between B2 and BC. They look exactly the same when you look at the memory. Okay? Your produce assembly or machine code doesn't mark this BC as a non-const or anything like that, if there are no optimizations. Okay? So BC will be just like B2 or B1. So you don't produce code that changes BC, and compiler makes sure that you don't produce that kind of code. Okay, so you had another question, Mohammed Sefa?
Yeah. What if define the struct or class like variable? Is it protect this then?
You mean the inside your class?
Just variables.
Inside your class, you have another object of another class, like composition?
Yes, or structure.
It's the same thing.
Or
You are saying that in your holiday class, can I make this const? Is that what you are saying?
No, I am saying that when we const in the function, it is predicting the variables, right?
Yeah.
when we create a structure or a class like variable, is it protect them? Like in our example, we definition the holiday and date.
Well, I mean, to make an, okay, there are two things. One thing is that when you create an object, you can make it a const. Okay, that's one thing. If
Okay.
instead of this holiday, if you are defining a struct, of course you can make the struct const. You can make the integers const. If this is what you are asking, yeah, I mean, you can make all the variables, including the objects and struct types and the fundamental types. You can always make them const.
Okay. Thank you.
Okay, thank you. It looks like I'm out of time for the first part of the lecture. Are there any questions before I stop? Okay, for some reason today, is it because of the sun? People started asking questions, or because of the const keyword? I think it is because of the const keyword, because other people are at home, they don't see the sun. Okay, let's take 10 minutes of break. Let's be here around 10:32. 10:32. Did everybody sign the sheet?
Hocam Windows sadece örnekleri bir sorun var ama bugün dersler alakası yoktur. Soramadım.
Neyle alakalı?
Windows sadece örnekleri bir satırla ilgili bir sorun var ama neden?
Neydi o sorun? Arkadaşlar sınıfı boşaltabilir miyiz? Şu camları da açın lütfen.
Hocam şu satırda constructor hiçbir şey return etmiyor dedik ama eşitledik onu nasıl yaptık?
Ya ben ama senin telefonunu bile göremiyorum. Sen bana telefonun ucunda
Constructor var ya şeyin
Ha.
içinde, klasın içinde.
eşitlemedik. O assignment. Ya eşitleme demeyin, deli diyorsunuz be. Ayrıca ben bu satırı da sevmiyorum demiştim değil mi?
Evet. O
Tamam. Yani bu
çalışmadı
esasında
zaten.
ha?
Bu zaten hata verdi burası.
Ne diyor?
Onu şu an hatırlamıyorum ama kırmızı yazdığını hatırlıyorum.
Hayır yok. Bir bak ona compiler'ına belki değişik versiyon falan kullanmışsındır. O hata vermez, çalışır ama orada yaptığı bank account'un bir tane geçici objesini yapıyor. O objeyi de senin o account değişkenine atıyor. Yaptığı şey orada o. Yani bir şey return etmiyor esasında. Yani obje yapıyor.
Hocam
İkiden küçük bir rakam çıkarsa demek ki abi yapamazsın.
Okay, let's move on. Again, we said that use of const is important. You should always use const whenever it is appropriate. And the idea is this: when you are designing a new class, okay, at the beginning make everything const. Really, I mean, just make everything. Of course, constructors cannot be made const.
Hocam,
Yes.
you're muted. We cannot hear you.
Really? How did that happen? I don't know how did they happen. Okay, how about now?
Yeah, it's okay. Thank you.
So make everything const. When you design a class, okay, make all the functions const other than the constructors, but sometimes immediately you recognize that update and input doesn't make any sense if they are const. So remove those consts. So the idea is try to make everything const as much as possible. It's not optional. I mean, you don't say output will not change anything, but I am not going to make const. No, make it const. And the same thing for the parameters. Make your parameters const references if they are objects of other classes. If they are basic fundamental types like doubles and integers, leave them as call by value. They behave like const already. So that's the rule. Okay, go back. All or nothing. So we are at the all side. Use always const. That's very important. Another C++ syntax that we are going to see in a few minutes is the inline functions. Actually, they are available in C, but in C++ it is more pronounced. Let me see it this way. Okay, inline member functions. Yeah. See, this is my definition of the bank account class. I have my constructors. I have my update and input and output. Okay. I will implement them when the time comes, but there are some very simple functions. For example, get dollars. It will just return the account dollars. I can implement these kind of simple functions inside the class definition. Okay. So get dollars, get cents, get rate. These are very simple functions, and I implement them in the class declaration. Okay. In fact, it is possible to implement all of these functions inside the class declaration. Okay, class definition here. It is possible, but we don't prefer it that way because why? This is for bank account, especially this part. Especially this part is for the customer, right? It is our interface. Customer looks at this part and he says that, okay, I will use this constructor and I will use this input, then I will use this set balance and etc. Right? So it is for the customer to see what is available and what is not. And you are not supposed to put implementation inside this class definition. But these are very simple functions. I mean, get rate just returns the rate. Get cents just returns the account cents. Okay? So instead of writing these after the class declaration, I just put these definitions, simple one-line definitions, inside the class declaration, and I said that that's fine now. Okay, so these are called inline functions. Inline functions. Inline functions are the functions that you implement inside the class, inside the class definition. Okay, it's kind of against the information hiding principle, abstraction principle, because what did we say? We try to hide away the details of the implementation from the user. But as I said, everybody knows how these work. Okay, get rate. If they are complicated, other than a simple getter, then I don't write. For example, the set balance. Set balance is not as simple as assigning a value to the balance because I need to check the values, right? Do some other stuff. So I kind of hide that away. Okay. And the other thing is that when you make a function inline, when you call this function get rate, in your assembly, okay, in your assembly conversion, there is no function calling. This code will be directly inserted at the position of function call. So there is no overhead of function calls for the inline functions. Okay, so it is efficient too. Try to make these kind of simple getters inline, and if the setters are simple too, make them inline. So that will help your compiler to produce fast code, because remember one of the concerns that we had with the getters and setters is that even for those kind of simple stuff, why am I writing getters and setters for this kind of simple stuff? Just make this account dollars, account cents, and the rate. Make it public and everybody can access it. No, we don't make them public. Okay, access has to be restricted for them. If you are going to change their values, you have to use the setters and getters. Okay, but setters and getters are functions. They are expensive to call. If you think that they are expensive for these kind of simple functions, okay, make them inline. When you make them inline, okay, there is no function call cost, because compiler will take this code and it will paste it. Okay, when you say account1.getRate, okay, it's a function call, right? Compiler will change it to a1.rate, because this one's simply returning a rate. So compiler is smart enough to make that change if the functions are inline. Yes?
And for inline, the member functions, could we use inline keyword instead?
Well, I didn't talk about it yet. I will talk about it in a few minutes. So inline function means actually a function that is not called. It is inserted inside at the position where you make the function call. That's called inline functions. Okay, but if you implement these functions inside your class definition, they become automatically inline. If you like to, for example, if you like to make, well, there is no inline functions here, but if you like to make, for example, this input and inline, you would put an inline keyword at the beginning. As you see, it's a bold inline. It's a C++ keyword, inline. Okay, so the void and bold, inline is bold. It's a C++ and C keyword. So this input function is inlined. So when you call this function input, actually there is no function call overhead. It will be inlined. Well, maybe I should be careful about this when I say inlined. This is just a suggestion only. Okay, you ask the compiler, don't make a function called as input. Okay, whenever I make an input function call, if it is more efficient, make it an inline. Otherwise, don't make it inline. And the same thing is for the inline function that I defined here. So the compiler may ignore this inline keyword that you have used, or compiler may ignore to put these inside insert the definitions of these inside the code if it prefers. So inline is kind of a suggestion. So if we keep this inline function idea, if we set it aside, the important thing here is that it is possible to implement any function that you like in your class definition. It is possible. But we only implement functions that are at most one lines like this, one simple line, a few words. Okay. For example, get balance is not a simple return something. It just takes the account dollars and adds account cents times 0.001. Okay. So it converts the cents to dollars and it adds them together and it returns it. So, but it's a very simple arithmetic here. It is fine since it is not longer than one line. I can just write it here. It is more than a simple return, but it is simple enough. Okay. Yes.
if I replace the rate with sine 30.0, is that still an inline function?
If you replace rate with
Sine 30.0.
you mean instead of rate I am going to write something, what you mean? Okay, let me,
Yeah, it doesn't make sense, but
yeah, I understand, but there are many things that doesn't make sense. I wonder which one you mean. Let me go to the, okay, not that one I guess. Okay, you are saying that replace this rate with 3 point like this.
sine 30.0, sine function.
Oh, sine, okay. So you, like sine of something stupid like this.
Yes. Is that still an inline function?
Yeah. Yeah. I mean, you mean that does the compiler, how am I going to get rid of this parentheses? Yeah, okay. This is how we are doing it. So of course it is an inline function. I mean, sine is no different than this plus operator. It's a function, and this one is function too. You mean that is it complicated that the compiler may choose to not inline it? Well, compiler may choose to not inline it this one, or that one. Okay. So to see what compiler does actually, you write this program and you look at the assembly. So to do that, what do you need to do? You go to your compiler explorer, right? And you check, where is my compiler explorer? Why is it so slow? You go to your compiler explorer and you take your whole program. Where is my whole program? Control A and Control C, and paste it in there. Okay, it compiled. Okay, now let's see the code. Where is my main? Okay, here is main, and if I click on it, how do I go to the corresponding part? And I have to scroll down. Main is here. Okay, so this bank account, which one is inlined? Do we have any inline stuff? Okay, let's do cout out, and which one? Account one dot get cents. Get cents are inline, right? And this one is account. Okay, this one compiled. Let's go to the main again. Where is my main? Okay, which one is that? 54. So it still makes a call. Even though I inlined it, there is a call, function call. Get sense const. So it makes a function call. But if I say maybe it is making a function call because of the debugging purposes, let's say optimize the code -O. In that case, let's go to main again. Where is my main? Did I miss the main? Okay, I think this is output. Since I optimized stuff, it shifted the positions of all the functions. Okay, when you see the main, just tell me. I'm scrolling it fast. Input and main is here. Okay, so which one is 54? I think this is 54. Yeah, see, it didn't call. Did you see it? This line 52, 53, and 54. These 3 lines correspond to line 54 there. I don't see any calls for get sends, right? There is a call for the stream insertion operator, which is expected, but there is no call for the get sends function, so it is optimized. But it doesn't matter, as I said before, it doesn't matter if you inline them or not. Compiler, while it is doing the optimization, generally ignores your inline directive or inline modifier, function modifier.
So it's possible if the if we define getSend function more complicated than just returning sign of 30.0, it may not be
inline. Yeah. Well, you can try it. Let's try to inline one of the complicated functions such as input. Okay. So where is my main? Main is here. Bank account. Am I using any input? Call. Let's go to main again. Welcome. Get sense. Yeah, 56. Let's go to 56. 56. 56 is which one? Yeah, it is calling the input, right? So this one is calling the input. Let's try to make it inline, that input function. Inline. Where is my inline? Where is my input? This is output. Update and input. Make this inline. Okay, compile. Yeah, it did that. Let's go to main. Let's see if 360 something, right? 3, yeah, is this main? Yeah, main. And where is my input? Okay, 56. Do you guys know how to, what is this? If I click on this, oh, okay, here it is. Yeah, I found it. Yep. So it looks like, yeah, it inlined it, right? This is inlined. Input. I don't see it. Yeah, exactly, it is inlined. So it took my advice. But if I don't do this minus or, maybe it will not inline it. So the point is, when you get this inline modification keyword, it is up to the compiler to inline it or not, because whether you inline it or not, okay, the result will be exactly the same. The result that you see on the screen will be exactly the same. It's a matter of efficient code or not, okay. So the question is, why don't we inline everything then? I mean, why, instead of making these function calls, why don't we inline everything? So the problem with this would be, if you inline many inputs one after other, so each one will be like 10 lines long, right? And if everything is 10 lines long like that, every time I make this call, it will make your assembled code large, okay? Once your code gets larger, it will be a problem, because, I mean, code might be fast, but it is large, so that's another problem. That's a memory problem. Also a cache problem too. If your code doesn't fit into the cache, it will run slower. Okay, so let's try this actually. Can we do this? And let's see what happens. I am clicking on it, nothing is happening. I am doing this, do this. No, I have to go all the way to 3 something something. Yeah, see, it doesn't inline anymore. So the compiler is smart. Compilers are very smart. It is smarter. It's smarter than ourselves, or at least myself. Okay, so well, why are you making me do these kind of experiments in the class time? You are supposed to do these kind of experiments yourself. Okay, this is the way of thinking. Why, if I do this and this, and what would I get? if I don't do this, what would I get? What does the compiler do? How come somebody was asking me a question during the lecture break? Whatever you said yesterday was a lie. It didn't work. Yeah. So that's kind of the feedback I like to get. I never try to tell you lies, but sometimes we have to. But all the things that I said yesterday was that lie. So if you are doing something that doesn't agree with what I did yesterday, so that means that there is a mistake, either myself and yourself. Most probably what you are doing is wrong. Okay, good. Any questions on this? Member initializers. Somebody asked me this before. Earlier than C++11, this was not possible, but now this is possible. You may have members, data members, and they are initialized like that. Okay? So when you say coordinate, in my public section I have the constructor. In my private section I have x and y, their values are 1 and 2. So in my constructor I don't have to initialize these x and y to something. They are already initialized. Okay, this is possible. But we kind of don't prefer this way because this makes it very incompatible with the previous versions of the C++. So try to, and this is not very readable either, because when I look at the constructor, I don't see any initialization. Kind of surprising. I have to go back to the definitions of this stuff. Okay, so just initialize it the way that we want using the initialization section and initialize it that way. By the way, I think I did not completely cover this class, okay, bank account. Let's look at this bank account now with the inline definition and the const keywords. Again, I have doubles here, okay. 4 constructors, update, input, output, and this stuff, inlined, set balance, and set rate. And these are my private data. And as you see, I have now 1, 2, 3, 4 private functions. Okay, so those functions are not supposed to be used by our customers, and they are for our internal use, and we are going to see it. And they are kind of, I don't like these functions being in this part of this class. Okay, I'm going to tell you why. Maybe I should tell you why in a few, just now. Okay, this dollars part, what does it do? Okay, it just casts this amount from a double to an integer and returns it. So if I have $2.50, it will just return 2. Okay, that's it. Line 34, I don't like it at all. Okay, this function should not be part of this class because what? Because why? I mean, in terms of syntax, in terms of compiler rules, it's okay, it compiles and runs fine. But in terms of using the idea of object-oriented programming principles, line 34, or this dollars part, should not be a part of this class. Can anybody tell me why?
Because objects can't access the function.
Say it again.
Object can't access these functions.
What object? You mean the bank account object?
Yes.
Bank account object can't
Access the private functions.
Well, that's why I make it private. I mean, our customers are not supposed to reach this part. I mean, I am not saying that this one should be public or private. I am saying that dollars part function should not be a part of this class.
Okay, I got that. Sorry.
I mean, it's a correct decision to make this private because I don't want our customers to deal with this kind of function because it has nothing to do with the bank account. Anybody else? Line 34, line 38, round. What does round do? Round will take a double, okay, and it will round it up to the next closest integer. How does it work? If it is 2.5, it will add 0.5 to it. It will make 3.0 and it will return a 3, okay? It is 2.1. It is 2.1. It will add 0.5. It will make 2.6. The floor of it will be 2 and it will return 2. So it is just taking a round. Okay, it is rounding it. Okay, so again, I am saying that this round function should not be part of this function, this class. The same thing for the fraction. What does a fraction do? It just takes a double, it just divides it by 100.0 and returns it. Yes?
They are too generic.
Just explain it a little bit more. They are too generic. What do you mean?
Not specialized for the class.
Not specialized for the class because they are not doing anything on the data, right? What was the idea of encapsulation? Bring all the data together and include all the functions that work on the data in the same capsule, right? Well, this is my data. All the set rate, get rate, update, input, output, they all modify or they access this data, all the functions. Okay, they work on this data. But how about this? These four, I don't see that they are working on my data, okay? They are not working on my objects, bank account objects. They need all the data from the parameter. They take this percent double and divide it by 100 and return it. They take this double number and it rounds it. This one returns the integer part of this double. Okay, this one will return, as you may guess, the decimal points of the double. That's it. Why should I make these part of my class? What would be the alternative? The alternative would be make them global functions. Well, that's even worse, right? I don't like that anymore. So that's not a good idea to make these part of my class. But for now, I will keep them here. Later, we are going to find very nice solutions for these functions. Okay, I will not them globals. Okay, I will not them regular members of function members of this class. I will find some other solution and we will come to that. Okay, so that is important to know, to understand why I don't like these four functions being part of. I like the functions. They are simple. They are nicely written. But I don't like the idea of these functions being part of the class definition inside the class. Okay, good. Any questions so far? Let's look at the implementation. I have two global functions here. Okay, although we don't like global functions, sometimes it helps us to understand what's going on. Islarger just takes two parameters. Okay, two bank account class objects, and they are nicely written by constant references. Nice. It looks like it will return true if account 1 is greater than account 2, or account 1 carries more money than account 2. Okay, and welcome is another function that takes single parameter, const reference parameter, and I guess it's going to print some stuff out. Okay, I didn't have to write these as global, so let's look at the definitions of them. Islarger just nicely does that. Okay, if account 1 has a larger balance than account 2, just return true, otherwise return false, right? And welcome does this. Okay, I didn't have to write global functions for these, but book, just for the sake of example, the book just does that. Let me try to make this part of the class. Actually, I will do that. I will take this in. I will take them, both of them, in my class, and I will make them my part of my public interface. And of course, it will not be exactly like that. So Islarger is going to be my function member. So his name is Islarger. It will take how many parameters now? Since the data member, it will just take one parameter. Let me get rid of this one. And it is nice to call the parameter what?
Other.
Yeah, exactly. You might say, why does it matter what you call the parameter? It is so important. I mean, here, account 1 and account 2 are perfect parameter names for this global function. Okay? But for this one, other is the perfect name. Why? Because I myself am a bank account. And I'm going to compare myself, okay, with another bank account. So it makes sense to call the other one other, right? Okay, this is the way of, okay. Do you think is larger is a good name? I'm going to use it like A dot is larger B. Yeah, I think it is good. Yeah, okay. How about this welcome? Okay. Okay, let's get this welcome. How about this welcome? How many parameters do you think it will take?
No parameters.
It will not take any parameters because it needs all that information. Okay, good. Are we done? Of course, we are going to implement them, but are we done with the function declarations? Since I am asking this question, I am waiting.
Const.
Yeah, we forgot about the const. That means that you have failed in the class. Yeah, this const. These are const. Remember, I had two consts. Let me try to make this kind of that. Why can't I do this? And that, okay. So look at this definition. It has two const keywords. One is for the one parameter, the second parameter. I have two const keywords here too. One is that I promise that I will not modify my parameter. The second one is that I promise that I will not modify my object. And this one, I promise that I will not modify my object. Okay, let's copy them out, and let's implement them here. One of them bool and one of them is that, and I guess bank account, right, is larger, and curly braces is this. I learned it. Yeah, and I will just return. Tell me, what should I write? Return.
Balance is greater than other dot balance.
Yeah, get balance is greater than other dot get balance. That's it. I am part of the class. I have access to the dollars parts and cent parts, right? Dollars parts and cent, those two integers. But I am not directly accessing them, even though I can, right? Because there is this nice get balance function that calculates all the balance, dollars and cents parts. So I am behaving like a stranger, like this one. Line 74, like a global function, okay? And welcome is going to be, okay, I'm going to copy, I'm going to kind of cheat, copy paste, const, and just output, that's it. So the book makes these two global functions. We don't like global functions, but I mean, it's a very nice example for me to explain you how to compare these const keywords between the global functions and the member functions. And the other thing is that this is how you make global functions parts of your classes. Okay, the same idea did not work for the dollars parts, cents parts, and round, because they don't work on my data of the objects. Okay, good. See, this is const and output is a const, right? What else? This is const, get balance, okay, it's const too. Question for you. I'm going to do something stupid. You might say that you keep doing stupid stuff. Yeah, well, this course is about stupid stuff. If you put all those stupid stuff together, it becomes something smart. Bank account B1. Okay, so it is 0, 0. B1 dot input. I don't know how I get. Well, oh, okay. These are the stuff. Now I see it. Okay. So this guy doesn't know how to write Turkish characters. Okay. Okay. Good. Since this is a const function, input is not a const function. Would line 69 compile? What did we say? Inside the const functions, you cannot call non-const functions, right? Well, I mean, the way I ask you is a tricky question, right? What?
B1 is a different object.
Yeah, well, the answer is yes. 69 compiles, even though input is not a const function, but I am calling it on this object B1, okay? I am not calling it on other, that, okay? This one will not compile. This will give me an error message. Also, this will give me an error message. Okay? So 70 and 71 are bad, but 69 is okay. So when I say you cannot call a non-const function a const function, the sentence is not perfectly correct. Maybe I should have said you cannot call a const function, a non-const function in a const function of an object. And those, okay, what did I say? You in a const function, you cannot call non-const functions on the same object. But for the other objects, of course, depending on the const definition, you may call them. Okay? Yes?
It's unrelated, but how do we send to a member function itself as an argument? For
How
example,
do we send?
The object itself as an argument for a member function.
Oh, myself. How am I gonna send myself to?
Yes.
Yeah. Okay. Well, you are saying that. You are saying that.
Isn't it already
You are saying, well, I mean, there is a way of doing it, but it will come later, okay? Because I don't know how to talk about myself yet. There is a way to talk about myself, self-reference, okay? And when the time comes, we'll see it using this keyword, and we will see it. You had a question?
I was gonna ask the same question.
Well, that's a good question, actually. I mean, how would I talk about myself? Well, maybe I should tell you that. I mean, well, okay, this time, while you're talking about it, there is a keyword, this, okay? This is a pointer to my object. It's a pointer, okay? This is a pointer. It keeps a pointer to my object. So when I try to talk about myself, I would say this, okay? That reference, this, is myself. Or if I like to call a get balance function